Hi guys, there was a question from section 4.3, problem number 53. So let me write the integral. So we have a definite integral from natural log of 3 to natural log of 7 of 4 times e to the negative x dx. Okay, so we asked to evaluate this this definite integral. So first of all, I'm going to go ahead and, as you know, there is a constant. You can always pull the constant outside your integral. I'm going to go ahead and pull the 4 outside. So now we just have integral from natural log of 3 to natural log of 7. And then of e to the negative x dx, okay? So I'm just going to quote a couple of, rules. If you go back to page 387 in your textbook, and look at property A4. So on page 387, property A4 says that because remember by fundamental theorem of calculus, the definite integral is just the antiderivative evaluated from the bottom, or from the top to the bottom. So if you look at that property A4, it tells you that integral of e to the negative x is 1 over a. Of course, this is your a, in this case, negative 1. So it'll just be 4 times e to the, or I should say negative 1 e to the negative x, and then evaluated from x equals to natural log of 3 to natural log of 7. Okay, so don't forget we still have the 4 outside of the whole thing. So this comes, so first of all, from here to here, we use that property on page 387. And then, of course, in section 4.3, this is what they call fundamental theorem of calculus. Once you have your antiderivative, you're going to evaluate it, okay? So I'm going to go ahead and take it upstairs. So from here, so this I'm just going to pull the negative next to the 4, so that becomes negative 4. And then we're going to plug in the top value first, which is what the fundamental theorem of calculus says. So I'll be e to the negative natural log of 7. Don't forget your x is, of course, natural log of 7 and then natural log of 3. So I'm just replacing x with the upper and lower limits. So that becomes e to the negative natural log of 7 minus e to the negative natural log of 3. Okay? And so, I mean, of course, you can evaluate this just approximation, but I think they want the exact answer. So we're going to go ahead and keep it exact. But at the end, of course, you can always approximate and give a decimal representation. But right now, I'm just going to keep it exact because I'm pretty sure they want you to come up with the exact answer. So now there is also a property. Let me quote them. I want you to go to page 199. Page 199, there's actually 2 properties of logarithm and also exponential functions. I'm going to quote both of them so you can go check them out. So on page 199, I want you to look at the property P3 and also P8, okay? With these 2 properties, we can rewrite this as, first of all, that negative 1, which is a coefficient, becomes an exponent. That becomes e to the natural log of 7 to the negative 1. Same thing here, that negative 1, we can make it an exponent. One of those properties allow you to do that. So that becomes e to the natural log of 3 to the negative 1. But of course, as you know, anything to negative 1 means 1 over that to the same power, as you remember from algebra. So we can rewrite that as e to the natural log of 1 over 7 to the first power, which of course is the same thing as 7, minus e to the natural log of 1 over 3rd, or 1 over 3, which is 1/3, okay? So let me just pause for a second. So really to go from here to here, we use one of the properties. I think it was P3, and then now we're going to use P8, that there is a property that says e to the natural log of any expression is just the expression, okay? In other words, e and natural log kind of cancel each other. So let me apply that. So both of those properties should be on page 199. They come from algebra, but of course, sometimes if you don't use it, you lose it. So you might want to go back and review those, okay? So I'm just going to rewrite that. So this becomes negative 4. And then, of course, so the e and natural log cancel, so that becomes 1/7. Same thing here, e and natural log cancel, which becomes 1/3. So now we're going to combine them into a single fraction. So 7 times 3, that's your LCD. Least common denominator is 21. So we multiply this one by 3 over 3 to make the bottom 21. Also this one by 7 over 7. Just to get the same denominator, so we can combine them to a single fraction. So that becomes negative 4. That's 3 over 3 times 7, which is 21, minus 1 times 7 is 7 over 21. So now, finally, we have inside brackets. So of course, 3 minus 7 become negative 4 over 21. So we have negative 4 times negative 4 over 21. Okay, now negative times negative become positive. 4 times 4 is 16. And of course, same denominator. So 16 over 21 should be your exact value for this definite integral. Okay, so I hope that helps. Let me know if you have more questions.